Hello and welcome to this episode of Math with Martinez. In today's video, we are going to be determining the value of trigonometric ratios of both side lengths and angles to solve problems involving trig ratios in mathematical and in real world problems. So what does that mean by finding the side lengths or finding the angle measures? Well, what you're going to notice here is that in these diagrams that we see, these examples, we don't have everything. We don't know all the side lengths or all the angle measures. And so we're going to practice finding those using the trig ratio that we have studied earlier in this unit. Those trig functions are going to be applicable and necessary in order for us to solve these right triangles. So let's go ahead and begin by being aware of the steps that are required for finding side lengths in right triangles. The first thing that you're going to need to do is circle the angle that you are referencing. In our case, that's going to be this angle right here. Then you're going to label the sides. That's step number 2, specifically the sides that we either know the value of or are looking to find. So the side where x is, what would that be called in relationship to our angle 32? Well, it is the hypotenuse. So let's label that hypotenuse. And what about the side that is 11? What is its relationship with respect to our angle? It is the opposite. So now that we have labeled our sides, we need to choose the correct function. Which function is it that is going to allow us to set up this relationship between our angle and the side opposite and hypotenuse? So which one is that? Well, ladies and gentlemen, that is going to be sine, because sine is opposite and hypotenuse. So I know that I need to use my sine function. Then I'm going to substitute and solve. We're going to substitute in the values into the appropriate locations and solve. Let's go ahead and do that now. So it is sine of an angle, sine of that angle, which is 32 degrees. The side opposite is 11, and the hypotenuse is what we're trying to find. That is x. Let me just kind of do a little dividing line here because we're going to move up to the next column where I have more room. All right, so technically, we've got a little proportion, right? Technically, this is been divided by a 1. Right, so I can kind of just do some cross multiplying and solving here. That would be x times sine of 32 would equal 1 times 11, which is just 11. And then I would need to go ahead and divide by sine of 32 degrees on each side, which will give me x equals 11 over sine of 32 degrees. And this is where you just grab your handy dandy calculator and we will round to the nearest tenth. So you type that in and you would find that 11 divided by sine of 32 degrees is about 20.8. Ladies and gentlemen, that represents the length of the hypotenuse in this first example. Let's go ahead and do another one following these steps once again. Step number 1, circle the angle that we are referencing. Let's circle that angle. We are working in this angle right here, which is 23 degrees. Then we want to label our sides. We want to label the sides. The side x is right next to that angle, so it would be called what? It is adjacent. And 30 is the hypotenuse. So which of our trig ratios relates an angle with the adjacent and hypotenuse That is cosine. Cosine of theta is adjacent over hypotenuse. And let's go ahead now and move on to step number 4, which is to substitute in the specific values for this problem and solve. That's going to be cosine of 23 degrees, the adjacent side, which is x, over the hypotenuse, which is 30. You know what? I've got room for this. I'm just going to start it up here at the top. All right. Now, ladies and gentlemen, what do we need to do to get x by itself? Right now, it's been divided by 30, so I'm going to go ahead and multiply by 30 on each side. That is going to be 30 times cosine of 23 degrees that I'll need to type into my calculator and round to the nearest tenth. When I do that, what is that value of x to the nearest tenth? That's going to be 27.6. There you go. We've got one more that we are going to work through here, where we are finding the side length. And then we're going to switch it up, and instead, we're going to look at finding angle measures. So let's do this 5th example. We want to begin by first circling our angle. Then, step 2, label your sides. X is that longest side. That is your hypotenuse. And 3 is right next to my angle. So it is the adjacent side. That means hypotenuse and adjacent, the trig ratio that relates those is what, ladies and gentlemen? That is cosine. We're using the trig function of cosine to relate these two sides and solve for our hypotenuse. So we'll go ahead and substitute in our values. This is cosine of 64. That is my adjacent side of 3 divided by x. This is technically over 1. In order to solve this, when our unknown is in the denominator, it's like what we saw in example 1. We're going to need to cross multiply. And then get x by itself by dividing by cosine of 64 degrees on each side. And then into our calculator, we can go ahead and type 3 divided by cosine of 64 degrees. And that will give us the measure of our hypotenuse. And what is that going to be, ladies and gentlemen? That will be 6.8. So these have been examples where we are finding side lengths. Now I want to switch it up a little bit and look at finding angle measures. Now given our trig value of an angle, we're going to use the corresponding inverse trigonometric function in order to find the measure of an angle. So what does that mean? That means, ladies and gentlemen, that when you have sine of theta equaling x, you could find theta by taking the inverse. We read this as inverse sine of the ratio x. For cosine, in order to find theta, if you were trying to find theta, then it would be that you would need to take the inverse cosine of x. And if you're trying to find theta and your function that you're working with is tangent, then you're going to take the inverse tangent of x in order to find theta. Now, like it says here, sine to that -1 power is read as the inverse sine of x, inverse sine of x, or here, inverse cosine of x, inverse tangent of x. We want to make sure that we can read our mathematical statements correctly. So let's begin. Once again, we want to start by circling the angle that we're working with and then labeling our sides. Identifying which trig ratio this is going to be. Which one will relate adjacent and hypotenuse, ladies and gentlemen, of the three? Once again, we have cosine. And now let's go ahead and substitute and solve. It is cosine of theta. We do not know what theta is, but it is going to be the ratio of 18 over 23. Now, like we just saw above, in order to solve for theta, we will need to take the inverse cosine of the ratio 18 over 23. That ratio is, this ratio right here represents the x in the above examples, or formats, I should say. And so then you just type that in your calculator. You have a button that is inverse cosine, and then it'll allow you to type in that fraction. We're going to round, and what does that round to, ladies and gentlemen? What is the approximate value of our angle theta? It is 38.5 degrees. Make sure that you do note that we're dealing with an angle, so we'll want to answer it in degree measure. All right, let's do just a couple more here. Let's look at 9. Once again, we want to start by circling our angle, then labeling our sides. 17 would be what in relation to our angle theta? Which side is that? That is going to be your opposite. And 18 is the adjacent. So we've got an example of a tangent function that we're working with now, which is opposite over adjacent. Let's substitute those values in. Tangent of theta is 17 over 18. But if we're trying to find theta, then what we'll do is take the inverse tangent of x. We'll take the inverse tangent of that ratio, 17 over 18. That is our x, that ratio. And with your handy-dandy calculator, we can approximate that value for our angle. What is that going to be? It is 43.4 degrees. Last one for our video here. Guys, we are trying to find theta, this angle. We have the length of 52, which is the, what is that, y'all? That's our hypotenuse. And 29 is the side that is opposite. So we are once again confronted with a sine function. So let's go ahead and substitute in. We are looking to find theta. We don't know what that is, but we know opposite is 29, hypotenuse 52. That means we're going to need to take the inverse sine of that ratio to find the angle. And what is that approximately, ladies and gents? You should have got 33.9 degrees. And that's it, y'all. That is solving for the side lengths and the angle measures in our right triangles using our trigonometric functions. If you had any questions while you were watching this video, please take a moment to share those now. And until next time, stay fired up.